Welcome back to G Fun Facts Online. Today we are diving deep into the fabric of reality itself. We are going to talk about a concept that sounds like it was ripped straight out of a comic book, but is actually rooted in the cold, hard equations of general relativity. We are talking about the gravity laser. And no, this isn't a weapon from Star Wars. It is something far more profound. It is a machine designed to twist spacetime, tame gravitational waves, and perhaps, just perhaps, open a door to the past. Let's get right into the physics of it. To understand the gravity laser, we have to unlearn something we are taught in school. We are taught that light is weightless. We flick a flashlight, and the beam doesn't drop to the floor like water from a hose. It travels in a straight line. But this is actually an illusion caused by the weakness of gravity. In the early 20th century, physicists realized that light carries energy, and thanks to Einstein's famous equation, E equals mc squared, we know that energy and mass are interchangeable currency. They are the same thing. If a massive rock can bend spacetime to create gravity, then a concentrated bundle of pure energy, light, can do the exact same thing. This is the foundation of the gravity laser. But simply shining a light beam isn't enough to build a time machine or a gravity drive. A straight beam of light creates a very weak, strange gravitational field that attracts matter but also has a repulsive pressure. To really grab the universe by the lapels, you have to do something else. You have to make the light spin. This brings us to a phenomenon known as the lens-Thirring effect, or frame dragging. Imagine space is a giant trampoline. If you place a bowling ball in the center, it curves the fabric. That is standard gravity. But now, imagine spinning that bowling ball incredibly fast. As it spins, friction causes the fabric of the trampoline to twist and bunch up around it. If you rolled a marble past this spinning ball, it wouldn't just curve in, it would get dragged sideways by the twisting fabric. This is frame dragging. Earth does this as it rotates, twisting the space around us. A fact confirmed by satellites like Gravity Probe B. So here is the billion-dollar idea. Since light creates gravity because it has energy, and rotation twists space, then a circulating ring of high-intensity light should twist spacetime into a vortex. This brings us to the story of Dr. Ronald Mallett. Dr. Mallett is a theoretical physicist at the University of Connecticut, and his work on the gravity laser is driven by a heartbreaking human motivation. When he was 10 years old, his father died of a sudden heart attack. Mallett, seeking comfort in books, read H.G. Wells' The Time Machine. He realized that if time is a dimension like space, physics might offer a way to go back and warn his father. That promise turned into a lifelong scientific quest. Unlike fiction writers who imagine time machines as metal boxes with flashing lights, Mallett looked at ring lasers. These are devices already used in aircraft navigation. He solved Einstein's field equations for a circulating beam of light and found that the gravitational field inside the ring would act like a spoon stirring coffee. The light is the spoon, and empty space is the coffee. As the light spins, it stirs space, creating a vortex. If you increase the intensity enough, that vortex doesn't just twist space, it twists time. It bends the timeline into a loop, known in physics as a closed timelike curve. If you were to walk along this curve, you would move forward in your own future, but end up in your own past. It is a staggering concept. But before you start packing your bags for the 1950s, there is a major catch in the theory. It is called the machine activation limit. Mallett's theory, and indeed most serious time travel theories, suggest that you cannot travel back to a time before the machine was built. If you switch on the gravity laser in the year 2050, you start twisting space from that moment forward. You could enter the loop in 2060 and cycle back to 2050, but the road to 2049 simply doesn't exist. The geometry wasn't there yet. This means Dr. Mallett can likely never save his father. The machine, if built, would only allow our descendants to visit us the moment we turn it on. Now, let's get into the weeds of how we actually achieve this twist, because modern photonics has given us a new tool called Orbital Angular Momentum, or OAM. For a long time, we thought of light waves as moving like flat sheets of paper. But in the 1990s, researchers discovered we can twist the phase of light so the wavefronts look like a fusilli pasta or a screw. This is called twisted light. This isn't just a shape, it carries physical torque. If you shine this twisted light on a microscopic particle, the particle actually starts orbiting the center of the beam. Theories published in journals like Physical Review D suggest that this twisted light couples to the geometry of spacetime much more effectively than a standard beam. It acts like a drill. This means we might not need a giant physical ring structure. A highly focused, ultra-high-energy beam of twisted light might be able to drill a hole in spacetime, concentrating that frame-dragging effect into a tight corridor. Labs around the world are already generating these beams for things like increasing internet bandwidth, but physicists are now looking at them as tools for spacetime engineering. This leads us to a more immediate application than time travel: gravitational mixing. We know gravitational waves exist. LIGO detected them from colliding black holes, but they are incredibly faint. However, theoretical physics suggests that high-intensity lasers can interact with these waves. It is called gravitational mixing. Imagine a device where a laser is tuned to resonate with the frequency of a gravitational wave. The laser could theoretically absorb energy from the wave, dampening it. This would be the first time humans could actually calm a cosmic event. Even more wildly, this interaction could convert a graviton into a photon. This means we could build a gravitational radio, converting the invisible ripples of gravity directly into flashes of light that we can detect. We could listen to the center of the Earth or the Big Bang with a device that fits in a room, rather than a detector that is kilometers long. But now we have to face the engineering nightmare. The math works, but the numbers are terrifying. Gravity is the weakest force in the universe. A fridge magnet can defeat the gravity of the entire Earth. To reverse this, to use light to make gravity, you need an astronomical amount of energy. Calculations suggest that to twist spacetime enough to fit a human, you might need the energy output of the entire galaxy compressed into a small cylinder. That sounds impossible. However, there are workarounds. One is resonance. Just as a singer can shatter a wine glass with the right note without screaming at the top of their lungs, we might find a resonant frequency of spacetime that lowers the energy cost. Another trick is slowing the light down. We have achieved slow light in labs using Bose-Einstein condensates, slowing photons from 186,000 miles per second to the speed of a bicycle. Since energy density depends on how long the energy stays in a region, slowing the light down causes the energy to pile up, skyrocketing the gravitational mass of the beam without needing a supernova's worth of power. But this brings its own problems. At those intensities, the vacuum of space starts to become unstable. The light could rip electron-positron pairs out of nothingness, turning your time machine into a particle bomb. And then, of course, there are the paradoxes. The grandfather paradox is the famous one. If you go back and kill your grandfather, you are never born, so you can't go back. Mallett subscribes to the many worlds interpretation, where going back creates a branching timeline. You kill a version of your grandfather in a parallel timeline, but your original self remains safe. Another view is the self-consistency principle, which says the universe will simply prevent you from changing the past. The gun will jam, or you will trip. You become an agent of destiny, only able to do what history says you already did. But let's look at the future. Even if we never move a person through time, a gravity laser could send information. Imagine a computer calculating a cure for cancer for 1,000 years, and then sending the binary code back to the moment it was switched on. We would get the answer instantly. This is hyper-computation, and it would change civilization overnight. Currently, we are taking baby steps. Dr. Mallett is trying to fund a proof-of-concept experiment to measure the tiny frame dragging of a ring laser. Facilities like the Extreme Light Infrastructure in Europe are firing petawatt lasers to test how light stresses the vacuum. We are like early humans looking at birds and dreaming of flight. Building a 747 seems impossible to a caveman, but the physics of lift are real. The physics of the gravity laser that light curves spacetime are equally real. It is just a matter of energy, engineering, and time. And if we succeed, time might be the one resource we finally have in infinite supply. Thanks for listening to this deep dive into the luminescent loom of reality. Keep looking up and keep wondering.